Hello everyone, I welcome you all in this video. In this video, we are going to discuss about one of the advanced casting process, that is continuous casting. Okay, so the continuous casting is a combination of two processes, that is casting plus one of the sheet metal operation, that is rolling. Okay, so through the casting, we are getting a semi-finished product, and after the semi-finished product we are applying the rolling in continuation, and we are getting a finished product. Okay, so in this video, basically the continuous casting is a combination of casting plus rolling. So in this video, we are going to discuss about the continuous casting process. So let's start. Is first, we also call this casting as a strand casting. Okay, so the meaning of strand casting, it the molten metal, which is molten metal which is solidified uh, in semi-finished product, now these semi-finished products are either a slab or square cross section. Okay, we also call this as a billet, rectangular cross section, we also call them as a blooms. Okay, now these are basically the semi-finished product. Means after the semi-finished product we are applying the rolling, and through the rolling the slab is converted into the small thickness sheets or the plates. The square section is converted into the rod or bars, and rectangular cross section is converted into the I section or H section. Okay, so these are basically the finished product, means which is a final product, and these are basically the semi-finished product. So these products we are getting through the casting, and these products we are getting through the rolling. So in continuation with the casting we are applying the rolling operation. So and that's why we are calling it as a continuous casting, or we are also calling it as a strand casting. Okay, so before the 1930s, or in between the 1930s and 40s, generally this continuous casting process was used for the non-ferrous material. But after that, because of the low thermal conductivity, yeah, because of the low thermal conductivity of the steel, as well as the high casting temperature, which is a melt above the melting point temperature. So because of these two properties, this process was finally adopted for the ferrous material. Okay, to produce the casting ingots. Ingots are what the semi-finished products are. Okay, so the semi-finished products are after the 1940s or in the range of in the 60s. Basically, this process was adopted for the ferrous material. Yeah, before that, we were producing this I section, which are used in the railway tracks. Okay, the sheet plates, small size thickness plates that were produced by the simple casting, or the conventional casting, we can say. Conventional mean here, like initially we have to prepare, like if we want to get a I section. Okay, if we want to get an I section of a specific length, then we were using the mold of this I section, and means number of molds we were using of I section, and we are filling the molten material into that. Okay, so once this molten material, this molten material which is solidified, then we are bringing out, and again we are filling with the next molten material. So like that, we were producing these I section and the plates. But as it is conventional, so it required a high main power, as well as the time were also consuming very high. Because of using of this continuous casting process, the production is reached nowadays, it's up to the 95%. Means most of the I section or the plates or at sections or bars or rods, that is generally produced through this continuous casting. Okay, yeah. Next is I just want to brief you about this casting by this figure. Uh, First of all, I want to tell you about what these elements are. First is like electric furnace we are using. After that, there is a tundish. Okay, electric furnace just to melt the material that we are using, and tundish is basically a ceramic shell. Okay, so this we are using to skim off the impurities. Okay, so whatever the impurities are there along with the molten material, that is skimmed off from this portion, and whatever the remaining amount of the molten material which is pure, which is transferred to the next section. Okay, apart from this tundish, we are using this section which is as mentioned over here, that is above the 20 meter. So also as per the length, what the product basically we want to produce, accordingly we are using this length of this solidifying shell. Okay, so this solidifying shell we are using. Okay, and outside of this solidifying shell, we are using the cooling water. The as we are continuously filling this solidifying shell with the molten material, so we want that the solidification rate should be increased. So for that we are using the cooling water. Okay, and after that we are using that X-ray transmitter. So X-ray transmitters are it will also control the pouring rate, as well as if there is any means air particles are there or gases are there, that is entrapped, means that gases particles are entrapped, so that we can recognize through the X-ray receivers. Okay, after that we are using the pitch rolls. So the purpose of pitch rolls to apply the compressive force on the product that we are getting. And at the end we are using the bottom part of this solidifying shell, we are using the dummy block. Okay, so these are the elements. Apart from it, this is a oxygen lens. So this oxygen lens are using for the cutting purpose. And apart from means if we can also use like shearing operation or the torch cutting apart from this oxygen lens. Okay, so generally we are using this oxygen lens to cut the material. Okay, like if we need a specific length of like 12 feet or 14 feet of the slab. Okay, so accordingly going after passing this 12 feet, we are cutting this through this oxygen lens. Okay, so next is again the next product will come towards the downward side. Okay, so like that we produce the final product. So these are the elements. Now we are going to discuss about the working of it. In the working, like as we are through this electric furnace, we are producing this molten material. Okay, which is at a high temperature, melted material. This molten material is poured into this tundish. Okay, now as I said, this tundish we are using to skim off or to remove the impurities. So whatever the purity of this molten material, that is only moving forward. Okay, now first before filling this solidifying shell, we have to keep this dummy block. Means we have to close it. Means whatever the molten material, that should not cross this one. So for that we are using this dummy block which is in closed position. Now as we are filling this molten material, now this molten material is coming through this. Okay, and start filling this one. As I said that this dummy block is closed. So this is start filling this one. Okay, once it will as it is moving from this position, and as I said, this is at 20 meter around. So whatever the molten material that we are filling, itself starts solidifying little bit. Itself start solidifying. Okay, so when it will reach to this little bit amount of the material, molten material, it solidify itself, but it is not completely solidifying. But up to the specific so we have to increase the solidifying rate. For that we are using this cooling water. Okay, now we have to there are flow rate as well as the velocities, and uh, which we are making accordingly, because this cooling water rate is also depends on uh, up to what height we are using. Because like up to a specific height we want that as the molten material is coming out continuously. So we want that up to a specific height, the material is completely solidified as soon as possible. Because if this material will solidify, then we are using this pinch roll. So the pinch roll is applying the compressive force on the product that we are getting, or the solidifying material is there. And it is by applying the compressive force, the uh, if there is any gap, means if there is any air particles are there, that is also released by applying this compressive force. And as I said, that up to a specific height we have to maintain, so that because we cannot stop this molten material will continuously coming out. If this if this height of the molten material is solidified, then means what we are doing is we are opening this dummy block, okay, because we kept initially it's closed, so we are allowing this solidified material to move out. Okay, for that we are the pinch roll that we are using, so that basically rotating, that is rotating in this direction. So because of that, it will this pinch rolls, it will apply a downward force to the solidified material. So this material start moving downward direction. So at what speed we have to keep this rolling? Okay, what is the rate of this that should be, this molten material should be completely solidified, that depends on the speed, as well as what amount what at what rate this molten material we are feeling. So these are related with the each others, so please keep in mind. So accordingly, once this material is up to this, it is completely solidified, we are bringing it out, and rest of the material which is filling over this which is filling over this is also coming in contact with the cooling water, so it's also start solidifying itself with the high rate. So once this material is come out, this portion will reach to the bottom. Okay, so as we have already kept uh, this dummy block in the beginning, means closed this dummy block, so whatever this portion, this section when it will come out automatically, the whatever the material over here, when it will reach to this dummy block, it automatically completely solidified. Okay, so because of this compressive force, because of this rolling, which is applying the compressive force, there will be a continuous movement of this uh, solidified part. Okay, so because okay, now there is one more thing, is that we are using this oil. Apart from this oil, we can use this solid lubricants. Basically, we are using this oil for the lubrication purpose only, but apart from it, we can use the solid lubricants like graphite. Okay, we are using this solid lubricant or oil to basically to give a to reduce the friction between this solidifying belt or the solidifying shell and the molten material. If there will be a no if there will be a friction, then this molten material will attach, because as it is means the solidifying rate is high, so there may be a chance that this molten material should attach to this shell and start means that will restrict the motion of the molten material which is above to it. Okay, so we want that whatever the molten material that is we are entering, means we are filling in this shell, that should move downward direction. Okay, so that can be possible when there will be no attachment with this solidifying shell and the molten material. So to reduce this friction, we are using this oil. Okay, this is this solid lubricants also provide a means self lubrication. Okay, so that's why we are using the solid lubricants generally. Okay, so this is basically the working of a continuous casting of the continuous casting. Like here, by the casting, we are using this molten material, and by using this roll mills, we are using the sheet metal operation. So it's basically a combination of casting plus sheet metal operation. Okay. Yeah. Next is what we have discussed till now. This is only written over here, that molten material from the furnace is poured into the uh, that ceramic shell, or we call it as a tarnish. So there the impurities are skimmed off. Next is, before starting the process, as I said, that dummy bar should be inserted, or it should be closed, which is at the bottom of the mold. Okay. The molten material is poured and solidifies on the dummy bar because it is closed, and then once the material is solidified, we are allowing the solidified material to move out, or we are withdrawing this dummy bar. Okay. Next is, because as I said that, because at what rate we are opening the dummy bar, uh, and at what rate the material is solidified, so we have to maintain the at what, and also what amount of the molten material we are filling. So we have to keep in mind, and accordingly we are flowing the molten material. Okay. So for that, as it's written here, that cooling rate, it says that the metal develops a solidified shell to support itself during the travel downward, which is just around the speed of 25 per second. Okay, and then which is passed through the pinch rolls. Uh, Next is about the solid lubricants that we are using. So that's basically graphite that is providing the self lubrication. Okay. Uh, Products length, as I said, that length is, if specific length is required, then we are using this oxygen length, oxygen for the cutting purpose, or apart from that we can use the shearing at the, or the torch cutting. Okay. Again, if the pinch roll, whatever the pinch rolls that we have provided, if we have to reduce the thickness again, then we can provide, once the solidified part is completely coming out. Okay. After that we can apply this rolling mills. Okay. So that from that the thickness of the sheet can be reduced. Okay. Next is, we are using, just I want to brief you about this. Okay, this is also nothing but it's same what we are using in the continuous casting. So this is a tandish, and this is a meniscus. Okay, meniscus means, means there is a formation of the meniscus. Means meniscus is just a curved shape of the liquid on the solidified part. Okay, so this sections in which we are using a high rate of the cooling. Okay, with the cooling water. So this is specific, whatever the area of cross section area is required. Basically, initially we have to maintain something, but after that we can change using the rolling mills. Okay. So initially we are using some specific cross sectional area. So whatever the molten material that is coming with the high amount of this cooling rate, the material gets solidified. As once it is solidified and it move out, that directly come in contact with this rolls. Okay. So this is rolls. Because of this rolls, this will start moving. Okay. This will start moving. Okay. So like that, we are producing the finished products. Okay. And there is one more thing, that is, these are rotating, these rolling mills. So there is no need to provide a specific mechanism which is pulling it out, because is this solidified shell which is in contact with these rolls, it's automatically, as it is, these rolling mills are rotating, so it automatically moves forward. Okay. In the direction where we need for the further operation. So it's automatically moving. There is no need to provide a separate mechanism to pull it. Okay. So this is also a type of the strand casting. Next is the same thing, but generally for the sheet, because there we need a because the thickness that we are getting for the, generally the sheets that we are getting for the roof shadings, that is are in the length of 14 feet to 20 feet. Okay. And this is length, and width if you will compare, then it is 3 to 4 feet. Okay. And if you will compare that, if you will see the thickness, then that is in the range of 2 to 6 only. So this thickness as comparative with the length and width is very small. Okay. Now if we have to use more rolls. Okay. So that this is only mentioned in this figure. Like here, apart from the rolling, we are using this belt. Okay, so this is a tight side and tension pulley, and this is slack side. Okay, so both the sides we are using this pulley, and apart from the pulley, inside of that we are using this backup rollers, so that also provide the excessive amount of the compressive forces. And we are using this high velocity water cooling water jets. Okay, so these jets are, you can see that number of jets are there, so the material itself gets solidified very easily. Okay, so whatever the molten material that is coming, okay, and initially we are using this water nozzle, so it starts solidifying from itself only. Now when it will reach to it, it will become a, it will completely solidified. Okay, now we are using this belt portion. Okay, because as I said, the thickness is very small and the width and the length is very high, so there won't be any deformation, because final product is very very important. So we want any deformation on the sheet part, so that's why we are using this um, separate method for that. Okay, otherwise this will also be fine. For the billet and the blooms, generally we use this billet and blooms, we are using this type of setups, and for this plates or slabs we are using these types of sections. Okay, so we also call this, by the way, this is a continuous casting only, but there is a separate name, that is strip strip casting. Okay, we also call this as a strip casting. Yeah. Next is the effect of the oscillation mold. If you will look at in this figure, like if you will see this figure, then these are the roles basically. And because as I said that there is no separate mechanism that we are using to pull it out, but because of these contacts only, it is moving out, it is moving forward. Okay, so as it is moving forward, and as I said that the thickness also generally is very less comparatively with the width and the length, so it start oscillating. Okay, it start oscillating, means the material, means whatever the product is there, solidified material, it's start oscillating. Okay, so because of this oscillation, this the surface profile of this final product is little bit affect because of this oscillation. So how this uh, how this surface profile is affect, that is only we are discussing in the next slide. Okay, so in the first figure, if you will see this figure number 4, then you will see that this is basically the steel surface that we are getting in the final product. Okay, which is required. Okay, means it should be like this, and you can see that these are the this some, you can see these sections. Okay, so it is because of the oscillation only. Okay, so because of this oscillation only, the surface profile will be like this, but it is little bit clean. But if you will look at the solidifying shell surface, okay, inside of this shell surface, then it will looks like somehow black portion. Okay, it is not clean what we are getting in this. So this is because of there is a possibility that this can be because of some amount of the material, because if sometimes there is no proper lubrication, then the material is material molten material itself cover the surface, and also there is like high temperatures we are using. So what we are doing, we are not using any separate molds to in which the molten material is poured, but simply we are using the solidifying section, so in which we are filling the molten material. So if you will see the surface, it will looks like black. Okay, this surface will be like, as comparatively with this is black one. Okay, but is this rolling is happen inside the, because this is a spraying this is the solidifying spale, inside only the material is there. Okay, so when you, we are using this rolling this at this position. Okay, so this will affect the solidifying shell as well as the solidifying metal. Okay, so solidifying metal profile, if you want to see this, this will be like this, and the inside solidifying shell will be like this. Okay, so this is because of these oscillations. One more thing is that this will also affect if we are using the grade of the carbon, means if we are increasing the rate of the increasing the carbon percentage, then the oscillations effect will be reduced. Okay, Now there are for this comparison we are using three grade of this, that is low carbon grade, peritectic steel, and the medium carbon steel. Now this Y section, this Y is basically is in micrometer, and this horizontal is in mm. Yeah, this is in mm. So when you will look for the ultra low carbon grade, then these peaks and these peaks are in the range. The range of this is quite high. Okay, so this and this difference between the low and the bottom, means top and the bottom peak, is also uh, quite high. Okay, so in between we are getting some sub peaks, but the length, this difference between the top peak and the bottom peak is quite greater. If we increase the percentage, then for the peritectic steel, then we will see that small size of means small size of uh, surface profile will be there, and suddenly there will be like peaks are there. Okay, so again it will be like small range. So these are basically, we are calling it as a plate use. Okay, and these are peaks, some bottom peaks. So this is the profile of this we are getting in the peritectic steel. And when we are increasing this carbon percentage, and we are comparing with this mild medium carbon steel, then you can see that these are, we are getting like this, but the peak is also not that much. Peak is like, it will be like this. Okay, so it is this profile is good as compared to with this one and this one. So that's why, as I said in the beginning, that this casting process was after the 1940s, or in the range of 1960s. This was applicable because of the low thermal conductivity and high temperature that we are getting. That's why it's applicable for the ferrous material as well. Okay, so this is all from my side in this continuous casting. Okay, if you want to study more, then you can go through these two references. Okay, these are wonderful, one wonderful book and the wonderful paper. And thank you so much from my side.